Intuitive Machines reveals the causes for its lander to end up sideways on the moon again. Firefly and Relativity give updates on the progress for their upcoming rockets. And this Australian launch company had a rather unfortunate and weird reason to scrub its maiden launch. As always, we'll have all that and more coming up this week in Spaceflight. Well, it's been another week, which means we've got more moon-related stories for you. Kind of crazy that this is becoming routine now, isn't it? We all remember when Intuitive Machines' Nova-C lunar lander landed on the moon, on its side, once again. For the second time in a row, one of these landers ended up on the lunar surface in the wrong orientation, without any clear reason why. Well, thankfully, now we have an answer as to what happened to cause that second mishap. During an Intuitive Machines earnings call on May 14th, officials mentioned that there were three main reasons why the lander ended up on its side. The first reason was due to Nova-C's laser altimeters. Apparently, signal noise and distortion had caused the altimeters to not receive the data that they expected upon landing, in turn leading to an inaccurate altitude reading. The second reason had to do with the shadows at the moon's poles. At such high latitudes, the shadows are long due to the sun being low on the horizon, which made it more difficult for the lander's visual navigation system. Along those lines, the third reason had to do with how the navigation system saw the craters of the lunar south pole compared to what it expected from the Lunar Reconnaissance Orbiter imagery used for navigation. So essentially, Nova-C believed that it was off course. The long shadows, combined with a closer distance to the surface, made the craters look different than those seen from up at the high altitude of the Lunar Reconnaissance Orbiter, leading to this discrepancy. So all of these issues combined to lead to a hard landing on the lunar surface and the subsequent tip over of Nova-C. Intuitive Machines said that they're learning from these mishaps and applying the lessons learned to the next two landers down the pipeline. For IM-3 and IM-4, they've stated that there will be redundant altimeters, which will be tested for flight conditions before launch. There will also be new sensors to measure surface velocity, as well as a larger crater database to ensure that the next lander, which is expected to make it to the moon sometime in 2026, will land right side up. While iSpace's second Hokuto R lander prepares for its lunar landing attempt in a few weeks from now, work continues on future missions, including those under its U.S. subsidiary, ispace-U.S. That U.S. side of the company is developing a separate lunar lander alongside Draper, based on Hokuto R, which they call Apex 1.0. This lander is slated to fly on iSpace's third mission, following the two flights of Hokuto R. For a while, iSpace and Draper had considered using the A2200 engine by Agile Space Industries for this lunar lander. However, the company recently announced a change to this plan. Instead, the company has decided to pivot to using Void Runner, an engine designed by both iSpace and Agile, citing it as the best solution to minimize technical and schedule risk for that third mission. According to the companies, this change reduces the number of individual parts required in each engine by a factor of 4. The engine also uses Agile's own valve system for throttling, which they argue will lead to higher confidence in the success of the mission. iSpace says that this change is also due to expected delays in the development of the A2200 engine, originally planned for Apex 1.0. That said, this change still delays this mission from 2026 to 2027, so we'll have to wait a little bit longer until that next mission. But in the meantime, we can still enjoy the second one a bit longer before its landing in June. And there was even more lunar news this week, including an unexpected payload for SLS. Now, you might know this already, but the SLS rocket doesn't just carry the Orion spacecraft to the moon, it can also carry CubeSats on its Orion stage adapter. In fact, it carried CubeSats to the moon on Artemis 1 on it. Now, this adapter is mated to the top of the interim cryogenic propulsion stage, the upper stage of SLS, and serves as a bridge to connect the upper stage with the Orion spacecraft. The adapter is large enough to carry some small payloads like CubeSats, which piggyback along on the rocket as it makes its way to cislunar space. As NASA prepares for Artemis 2, the next launch of SLS, they've been partnering with different agencies worldwide to provide CubeSats on this payload adapter. This week, the agency announced that it had partnered with Saudi Arabia to fly their own CubeSat on Artemis 2. According to the agency, the Saudi CubeSat will, quote, measure aspects of space weather at a range of distances from Earth. This Saudi CubeSat will join other CubeSats from the German Space Agency and the Korea Aerospace Agency on Artemis 2. One thing we're uncertain about, though, is whether these will survive SLS's schedule or not. Last time around, on Artemis 1, the payloads had to be integrated well ahead of time, more than a year before launch, and this led to quite a few of them running out of battery power before they could even be deployed in space to recharge their batteries. Others suffered different issues that were thought to be related to their long-term confinement in the rocket stage adapter. So here's hoping that that doesn't happen this time around. Now, of course, during Artemis 2, the main event will be Orion and its first crew going around the moon, but you can bet we'll be keeping a close eye on the health of those CubeSats as well. So if you want to follow along for stories like this in the future, subscribe to our channel to make sure that you won't miss it. It's free, and if you like our videos, hit the like button. That also helps the algorithm to spread the word to even more space nerds out there. We all love the colorful light displays of auroras here on Earth. They happen when charged particles from solar wind interact with our planet's atmosphere, but they're certainly not exclusive to our home planet. In fact, we've got 2 stories about aurora across our solar system. On Mars, we got our very first observation of an aurora in visible light. And what makes it even more special is that it was observed from the planet's surface by NASA's Perseverance rover. So we even got to see what it would look like if we were even there. Unfortunately, the Martian auroras are rather disappointing compared to the fabulous light shows that we get here on Earth, and that's because of a key difference between the 2 planets. On Earth, the particles from solar wind are captured in the planet's magnetic field and funneled towards the poles where they enter the atmosphere. As these particles excite oxygen atoms, they emit that beautiful greenish light. But the color can of course vary depending on the properties of the atoms, so other colors are available. Well, Mars doesn't have a magnetic field, so the particles enter the atmosphere wherever they happen to cross the planet's path. Scientists expected that they might still produce that same green light, only much fainter. But to see that, they had to get a little creative and get the timing just right. In March of 2024, the sun produced a solar flare that sent a stream of particles towards Mars. The Perseverance rover pointed its Mastcam Z camera at the sky to observe the event in visible light, and the noisy image that it produced showed a slight green tinge that wasn't present in other images that had been taken during a different night when there was no aurora. To confirm the effect was indeed caused by solar particles, the team employed the help of NASA's MAVEN mission and ESA's Mars Express. Both spacecraft detected solar particles, so the green glow in the image was indeed the first ever observation of a Martian aurora in visible light. While Mars's auroras are faint, Jupiter gets an even better show. The gas giant's auroras are 100 times brighter than those on Earth, and this week we got to see the light show in images taken by the James Webb Space Telescope. Webb observed the Jovian auroras on Christmas in 2023, but they were published this week alongside a scientific paper analyzing the observations. Now, it's no surprise that Jupiter's auroras are so intense, as the planet has a very strong magnetic field, but it also has an extra source of charged particles responsible for the light show. Volcanoes on the moon Io spit out charged particles that end up in the magnetic field, where they're accelerated into the Jovian atmosphere. The result is a dynamic and lively display of light, clearly visible in Webb's images. The scientists expected the auroras to slowly fade in and out over a longer period of time, but what Webb observed was much more spectacular, with changes appearing by the second. And it's not just pretty pictures. Analyzing the light show teaches scientists a lot about the planet's atmosphere and magnetosphere. Of note, Hubble took pictures of Jupiter in ultraviolet light when Webb was observing the auroras, but the brightest lights in Webb's infrared images don't even show up in Hubble's images at all. This puzzled the scientists, who now want to study what caused these differences. So there's still much more to learn about the solar system's prettiest light shows. Now we'll take a look at some other stories across space, starting with Relativity Space, which gave an update on Terran R's development just a few days ago. The final development versions of the rocket's Eon-R engines have performed gimbaled hot fire testing at NASA's Stennis Space Center in Mississippi. These 3D printed engines use liquid methane and liquid oxygen as propellants, and these tests of the integrated propulsion system bring the company one step closer to engine qualification later this year. Liquid oxygen tanks and vaporizers have also arrived on site at the historic A2 test stand at Stennis. Relativity is leasing the stand from NASA and is converting it to test stages as well as engines. A2 has a rich history of high-thrust engine testing, from the J2 engines used on the Apollo missions to the RS-25s of the Space Shuttle program, and most recently SLS. In Long Beach, Relativity is completing a structural test stand for Terran R, while early load testing has begun on a prototype barrel. Avionics hardware has undergone vibration vibration and thermal testing, while the software has successfully reached orbit in isolation. The company says it will move to hardware-in-the-loop testing later this year. Over at the Cape, the first steel columns are now in place for the horizontal integration facility at LC-16. Relativity is also reinforcing the pad here to handle the increased thrust of Terran R, which is targeting a launch no earlier than 2026. Firefly completed its first flight dome for the Antares 330 rocket and for what will eventually be Firefly's own medium launch vehicle. This dome is what Firefly calls the A330 S1RP dome. That's the dome on Antares 330's first stage kerosene tank. Now this one's special not just because it's a flight article, but because it was also the first to be built using Firefly's automated fiber placement machine. This machine makes complex dome shapes easier to build by allowing Firefly to make the dome 35% lighter while also completing it 3 times as fast. Due to the specific shape of the dome, the carbon composite material has a hard time laying out and staying put in the right shape, but using automated fiber placement, the domes can be made more consistent and accurate to one another. This consistency will result in a higher overall quality of the dome. Firefly already uses this method for building the barrel sections of the rocket, but this was the first time doing so with the tank dome. Once the dome is complete, it'll be integrated with the barrel section to create the final tank section. This specific tank will then be sent to Northrop Grumman for use in Antares to resupply the International Space Station. Completing this dome section is a big step towards Firefly's goal of launching MLV in 2026. Blue Origin is partnering with Viasat to launch 2 new telemetry demonstration missions for NASA's Communications Services project. Viasat's in-range telemetry relay will showcase uninterrupted real-time data using the company's planned L-band satellite network in geostationary orbit. This will provide continuous data during launches and orbital missions, even when the vehicles go into communication blackout areas where traditional ground stations are unable to maintain contact. The new technology is intended to replace NASA's Tracking and Data Relay Satellite System, or TDRS. This system has provided near-continuous communications for spacecraft in low Earth orbit since the early 80s, but the satellites are approaching the end of their operational lifespans. Last November, NASA declared that no new missions would be onboarded to the aging TDRS system. 6 companies were awarded contracts in 2022 to demonstrate commercial replacements for the TDRS system, including SpaceX and Amazon. New Glenn will launch the first of 2 Viasat demonstration missions later this year, and a second in 2026. The new services are expected to become operational by 2030 to align with the retirement of the International Space Station and the decommissioning of the TDRS satellites. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. This week was a busy one, starting off with the Starlink launch on May 10th. Falcon 9 lifted off from Vandenberg Space Force Base in California at 19 minutes past midnight UTC, adding 26 Starlink V2 mini satellites to the constellation. SpaceX used booster B1081 for this mission, and after successfully touching down on the drone ship Of Course I Still Love You, it's now logged 14 flights. Over on the other coast, we had another Starlink mission just over 6 hours later. Falcon 9 lifted off from Space Launch Complex 40 at Cape Canaveral with 28 Starlink V2 mini satellites on board. The mission was flown by booster B1083, which has some impressive missions to its name, flying Crew twice on Crew 8 and Polaris Dawn, and launching the IM-2 Lunar mission in February. It flew for the 11th time this week and successfully landed on SpaceX's drone ship A Short Fall of Gravitas. Around the time that mission took off, an unusual spacecraft also returned to Earth. Now, originally, this spacecraft was set to touch down on Venus, but it clearly didn't make it that far. In late March of 1972, the Soviet Union launched the Venera 8 mission, which successfully landed on Venus later that year. However, a few days after that launch, another spacecraft was launched from Baikonur, which is believed to have also been destined for Venus. Unfortunately, a failure occurred and it never made it beyond Earth orbit. This spacecraft was later designated as Cosmos 482. Well, it stayed in that orbit for many years, slowly decaying over time, and this week it finally re-entered Earth's atmosphere. As the spacecraft was designed to survive its descent through Venus's extreme atmosphere, the capsule might have even survived re-entry, but we just don't know for sure if it did. Determining the exact time and location where the spacecraft re-entered proved to be immensely challenging, as there are a number of factors that affected where and how the spacecraft entered the atmosphere. According to Roscosmos, this happened above the Indian Ocean on May 10th at 6:24 UTC, but the European Space Agency estimated it 8 minutes earlier, meaning that it would have re-entered over Central Asia, but there's also an uncertainty of plus or minus 22 minutes attached to ESA's estimate. So far, we haven't seen any reports of people witnessing the re-entry, so fortunately, the spacecraft most likely came down far from any populated areas. Next, we had a launch from China. A Chang'e 6A took off from the Taiyuan Satellite Launch Center on March 11th. Its fairing was loaded with 3 remote sensing satellites, which were delivered into a polar orbit. According to official statements, the purpose of these satellites is to probe the electromagnetic environment. Reportedly, the launch campaign for the Chang'e 6A has now been shortened to 14 days, clocking the rocket's turnaround record at 22 days since the previous mission on April 19th. A day later, a Chang'e 3C launched from Xichang. The rocket lifted off from the spaceport's Launch Complex 3 on May 12th at 1809 Universal Time. It carried a single satellite into a geostationary transfer orbit, which, according to official reports, is meant to verify multi-band high-speed satellite communication technology. But that's all we know about this classified satellite. On May 13th, we had 2 more Starlink missions, the first of which also happened to be the 100th orbital launch attempt of the year. It lifted off from Vandenberg at 1:15 UTC. Falcon 9's fairing contained 26 Starlink V2 mini-satellites, which were delivered into low Earth orbit. The booster on this mission was B-1088, and it ended the mission by successfully landing on SpaceX's drone ship, Of Course I Still Love You. B-1088 now has 6 flights under its belt. A few hours later, the next Starlink mission took off from the Kennedy Space Center at 5:05 UTC. The mission delivered 28 Starlink V2 mini-satellites into low Earth orbit. The mission was flown by SpaceX's most experienced booster, B-1067, which became the first to fly 28 times, just over 28 days after its previous mission. And there's likely more to come, as it perfectly executed its 28th landing by touching down on the deck of Just Read the Instructions. We had another capsule re-enter this week, but unlike the Venera probe, this one was actually meant to come back to Earth. We also know exactly where it landed on May 14th at 2:07 UTC. The capsule of Varda's W3 mission touched down under a parachute at the Kuniba Test Range in South Australia. This was Varda's 3rd mission, which was launched aboard the Transporter 13 mission in March and returned just 11 weeks after the previous mission touched down successfully. The company is developing these capsules specifically to return materials from orbit to enable space-based manufacturing. The payload on this mission was an inertial measurement unit, or a navigation system, provided by the U.S. Air Force to test if it could withstand the re-entry speeds that it was designed for. Back in China, a Chang'e 2D took to the skies above Zhochuan on May 14th. After lifting off at 4:12 Universal Time, the rocket carried 12 satellites into a sun-synchronous orbit. The satellites will test on-orbit data processing technologies and inter-satellite laser links. The ultimate goal of this program is to build a constellation to perform initial data processing for other satellites. Traditionally, this would have been done on the ground, but that approach is limited by data link bandwidth with the ground stations. Moving this step to a space-bound data processing system makes the process much more efficient. Later that day, we had another Starlink mission from Florida, with T0 occurring at 16:38 UTC on May 14th. Falcon 9 lifted off with 28 Starlink V2 minis to add to the constellation. The booster for this mission was B-1090, which flew its 4th mission and successfully landed on SpaceX's drone ship, a Shortfall of Gravitas. And now to Australia for an interesting launch that didn't happen. What did happen was actually kind of weird. The front fell off. So what exactly went down in the land down under? Well, Australian rocket company Gilmour Space had planned to launch the maiden flight of its Eris rocket this week. This would have been the first orbital launch from Australia since the United Kingdom's last Black Arrow launch in 1971. Gilmour Space got approval from the Australian Space Agency on May 13th, and the company planned to launch the next day. Then, a technical issue in the ground support systems delayed the launch by 24 hours, setting it up for May 15th UTC, or May 16th local time. However, Eris wasn't meant to fly that day. Gilmour performed some final checkouts the night before, and during those procedures, the rocket's fairing accidentally deployed following an electrical fault. This fairing protects the payload during the first minutes of flight, and is only meant to deploy once the rocket has left most of Earth's atmosphere behind, definitely not on the launch pad. Gilmour has since moved Eris back to the vehicle assembly building, where engineers will fit a new set of fairings, and we assume thoroughly check their staging. The company wants to get to the root of the issue before the next launch attempt, which is now delayed by at least a few weeks. And don't worry, despite the fairing's failure to protect the payload, Gilmour confirmed on social media that the jar of Vegemite that served as the mission payload had survived the untimely fairing deployment. And wrapping up the week, there was another Starlink mission launching from Vandenberg. Bet you didn't see that one coming. This time, Falcon 9 carried a batch of 29 V2 mini satellites into low Earth orbit, and the mission's booster, B-1093, successfully ended its second mission on the deck of drone ship Of Course I Still Love You. In total, we had 6 Starlink missions this week, and I think that's a record. Including those launched this week, SpaceX has now launched a total of 8,664 Starlink satellites. Of those, 6,676 are now in their operational orbit, and 1,138 have returned back to Earth. Next week is shaping up to be another busy week, with spaceflight events expected all around the world. We'll see 2 Starlink missions, and if the schedule holds, the second of these will mark SpaceX's 15th Starlink flight in a row, following the Bandwagon 3 mission a few weeks ago. Over in New Zealand, Rocket Lab is set to launch another radar satellite for IQPS. India is also planning to launch a radar satellite this week on their PSLV rocket. The current schedule also includes 3 potential launches from China on 3 different rockets: a Changzheng 7A from Wenchang, a Kinetica 1 from Zhochuan, and a Series 1S from a ship stationed off the coast in the Yellow Sea. SpaceX's CRS-32 cargo mission is also expected to return from the ISS next week. It's currently scheduled to undock from the Harmony module on May 22nd and will return to Earth for a splashdown in the Pacific off the coast of California. But next week's main event might just be a Starship mission, or so we hope. As you probably know, SpaceX is gearing up for Starship's 9th test flight, having already tested both Ship 35 and Booster 14, the 2 vehicles flying on that mission. As of recording, the latest hazard notices show that a launch could happen as soon as May 22nd, and if so, that launch will happen in the early evening local time, around midnight UTC. Just this week, the FAA confirmed that it had approved the license modifications needed for the rocket's 9th flight. But since the previous flight ended in a mishap, it needed a mishap report. Therefore, Starship's 9th flight won't be able to launch until either the FAA closes out that report or makes a return to flight determination. Ahead of this 9th flight, both SpaceX and the agency have conducted a short environmental assessment to update airspace closures ahead of launch. These updates come as a result of the failures from Flights 7 and 8, which scattered debris over the Caribbean, with some even reaching inhabited areas of Turks and Caicos. According to the assessment, the new aircraft hazard area is projected to affect over 175 flights, almost all of them international flights. The document also states that the average expected delay for flights going through that area would be approximately 40 minutes, but it could also be up to 2 hours. That said, the FAA also agreed that none of these changes would significantly affect the environment, with the highest impact being as a result of a launch anomaly that could scatter debris once again. Diverted flights would also consume more fuel and therefore emit more greenhouse gases, but the scale of this impact would still be minimal. For this reason, the FAA released a Finding of No Significant Impact, or FONSI, stating that the changes to the aircraft hazard area could be integrated into the updated license for Flight 9. So with most of the paperwork out of the way, pending either the mishap report being cleared or the return to flight determination being signed, the question is, will Starship be ready for flight next week? It's probably worth mentioning that of the paperwork previously mentioned, the FAA said that the Flight 8 mishap report wasn't submitted until May 14th, and the FONSI for Flight 9 wasn't signed until May 15th, so that's cutting it close. As for the hardware, well, Ship 35 just completed its minute-long static fire test on Monday, May 12th, and it's been in Mega Bay 2 ever since. If SpaceX wants to launch in the coming days, we'll need to see it roll out soon, otherwise that will also be cutting it close. It probably doesn't help that we've also recently seen an engine leaving Mega Bay 2, which could indicate a change of engine on Ship 35 once again. It's all a little bit confusing, but as always, we'll try to stay on top of this as the events unfold. Also, as always, you can expect even more updates and more analysis about this and other Starship-related events on our next Starbase Update episode. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.